Before we delve deeper into AI or artificial intelligence, we should first understand the definitions of AI and its subfields, namely machine learning, deep learning, and the associated artificial neural networks. There are many similar diagrams of AI available online as they perfectly illustrate that machine learning and deep learning are both subfields of AI. Artificial intelligence is the overarching term for machine learning and deep learning. Thus, while all machine learning is AI, not all AI algorithms are machine learning, let alone deep learning. For instance, rules engines can be considered part of AI, but they are not related to machine learning. Broadly speaking, artificial intelligence refers to a program or computer-controlled robot capable of performing tasks that are typically associated with human capabilities. Machine learning focuses on algorithms that can autonomously learn from data without being explicitly programmed. Deep learning takes this step further by utilizing artificial neural networks that mimic human complex decision making to learn from vast amounts of data. First, let's look at the historical development of AI to arrive at the current definition of artificial intelligence. The discussion about AI began in 1950 with Alan Turing, who posed the question, can machines think? He also developed the Turing test, which assesses whether a computer program or a machine possesses human-like intelligence. A few years later, in 1956, the term AI was coined by John McCarthy. He said it is the science and engineering of making intelligent machines, especially intelligent computer programs. A modern ISO definition states AI is a technical and scientific field devoted to engineer systems that generate outputs such as content, forecasts, recommendations, or decisions for a given set of human-defined objectives. In general, a distinction is made between strong or general AI and weak or narrow AI. Strong AI is a theoretical form of AI that is as intelligent or even more intelligent than a human, possesses a self-aware consciousness, and can solve new problems it has not specifically been trained for. IBM states that a strong AI can perform a variety of functions, eventually teaching itself to solve new problems. Such an AI does not exist yet, at least not to public knowledge. Weak AI, on the other hand, is designed to solve specific tasks. It still requires human interaction to set learning parameters for the algorithm and provide appropriate training data. Let's move on to the field of machine learning, or ML in short. Here we will start with two definitions. The first is from Stanford University, which states that machine learning is the part of AI studying how computer agents can improve their perception, knowledge, thinking, or actions based on experience or data. For this, ML draws from computer science, statistics, psychology, neuroscience, economics, and control theory. Another definition from IBM says that machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. The core idea from these definitions is that machine learning improves over time by learning from data that is presented to them. Let's break those definitions down further, since they might still seem abstract. Basically, machine learning is used to address two types of problems: regression problems and classification problems. In both cases, machine learning aims to solve a geometry problem. In regression problems, the goal is to fit a curve or a hyperplane to the data as accurately as possible. We seek a function that describes the data well enough to predict a new point on this curve or hyperplane. In classification problems, the objective is to separate categories or labels as accurately as possible. Here we also try to find a curve or a hyperplane, but this time it is meant to divide our data as accurately as possible. In both scenarios, the aim is to find a curve or a hyperplane that can best describe or separate the data. There are videos that describe machine learning as fancy curve fitting, which may seem oversimplified but isn't too far from the truth. In machine learning, as well as in deep learning, there are different ways for the algorithms to learn. Often this involves supervised learning. In this approach, labeled data is used, meaning we have both input data or features and the corresponding solutions or targets. This allows us to measure the accuracy of the model effectively since we already know the solution. The model learns from this data and gradually improves its accuracy until it is good enough to be used on new data for which we do not know the target value. Then there's unsupervised learning. Here, the correct solutions or targets are unknown. We only have our input data and don't know, for example, which class they belong to. The machine learning algorithm works independently to identify inherent data structures and hence is often used for clustering data into groups with similar features. Two special types of learning are semi-supervised learning and reinforced learning. The former describes having a small labeled training dataset and expanding it with unlabeled data. In reinforced learning, the program learns from its mistakes. It is rewarded when it does something right and punished when it makes an error. For instance, consider a car in a video game driving down a road. If it hits objects, it gets penalized. And if it successfully navigates through a course with obstacles, it gets rewarded. This way, the car learns to master course better over time. This principle can also be applied to robotics or other machines. Now, let's move to the final part of AI that we will cover: deep learning. Before diving into deep learning, let's start with the definition of artificial neural networks, or ANNs in short. This definition comes from Wikipedia, which, though it's not the most scientific source, provides a simple and good explanation. ANNs are computing systems inspired by the biological neural networks that constitute animal brains. An ANN is based on a collection of connected units or nodes called artificial neurons, which loosely model the neurons in a biological brain. Each connection, like the synapses in a biological brain, can transmit a signal to other neurons. An artificial neuron receives signals, processes them, and can signal neurons connected to it. To better understand this definition, let's break it down. First, focus on the illustration of a single biological neuron in the lower left corner. A biological neuron has dendrites where information arrives. This is the input the neuron receives. In the axon hillock, some processing occurs, resulting in an electric signal being transmitted to generate an output and a synapses. Similarly, with artificial neurons, we also have inputs, which are numbers in this case. These inputs are fed into a function, and the result of this function is the output which is passed on. On the right side, we see that biological neurons can be chained together. The output of one neuron can simultaneously be the input for the next neuron. Similarly, we can also chain several mathematical functions. We have inputs fed into functions, and the results of these functions serve as an input to the next function. Essentially, artificial neural networks are nothing more than chaining multiple mathematical functions. Each function has inputs and a single output. Having clarified what an artificial neural network is, we can now define deep learning. Stanford University defines deep learning as follows. Deep learning is the use of large multi-layered artificial neural networks that compute with continuous real number representations, a little like the hierarchical organized neurons in human brains. IBM's definition is slightly longer. Deep learning is a subset of machine learning that uses multi-layered neural networks called deep neural networks to simulate the complex decision-making power of human brains. Deep learning eliminates some of the data preprocessing that is typically involved with machine learning. These algorithms can ingest and process unstructured data, like text and images, and it automates feature extraction, removing some of the dependency on human experts. Although these definitions already describe well what we learned about artificial neural networks, let's further break down deep learning. First, we need to understand that deep learning uses artificial neural networks. Unlike in machine learning, we don't need to worry about which features or input values in our data are essential for training the model. The neural network determines this itself. And from a programming perspective, it sometimes comes down to one more line of code that differentiates machine learning from deep learning.